everyone, good afternoon. I'm Siti Tamira and today I'm going to talk about weather hazard that affect flight and airport operation. It's called icing. What is icing? Heavy hail. It's one of the major weather hazards to aviation and it is a cumulative hazard. Icing can occur if an airplane passes through a cloud when the air temperature is at or below freezing. It can happen during widespread rain, scattered shower, or even in the thunderstorm. Icing condition exists when the air contains droplets of super cold liquid water. Icing conditions are characterized quantitatively by the average droplet size, the liquid water content, and the air temperature. The first weather hazard formation for icing is rain ice. It's rough, opaque, milky white in appearance and most likely to occur at temperature of -10 to -20 degrees Celsius. More dense and harder than frost, but lighter, softer, and less transparent than clear ice. It occurs in stable conditions, cloud where the water droplets are small and freeze instantaneously, such as stratiform clouds and the upper portion of cumulus cloud. It's brittle and fairly easy to break off and does not normally spread over an aircraft surface, but protrude forwards into the airstream along leading edge of airfoils. So this is the example of run ice as you can see. Alright, next we move to clear ice. It normally occurs at temperature between 0 and -10 degrees Celsius, where water droplets are large because of unstable air such as in cumulus cloud in areas of freezing rain and drizzle. It's the most severe form of icing because it builds up fast, can freeze the flight controls and disrupt airflow over the wings. Next is a mixed ice. It's a combination of clear ice and rain ice. The temperature was -8 to -15 degrees Celsius. And its most frequent type of icing encountered is usually a form of mixed ice.
Hello, I'm Vinita. Next is freezing rain. Icing can also occur when a plane is on or near the ground as a result of freezing rain. Atmosphere can set up such that a warm layer about 3 degrees Celsius and about 500 feet thick also can ride over top of a shallow cold layer which is -1 degree Celsius and 3,000 feet thick near the ground during the winter season. Ice crystals forming in the upper atmosphere form through the warm layer and melt to become liquid. Then, the liquid also falls to the cold temperatures and refreezes on contact with surface on the ground. Next, high altitude ice crystal. Type of ice can be hazardous in just at high altitudes. Usually occur in or near convective weather such as thunderstorm in a tropical environment at high altitudes. Ice crystals do not accumulate on the airframe, can quickly melt and stick to relatively warm internal engine surface, can cause engine flameouts and subsequent start or engine damage. Next is porous ice. Result of water freezing on unprotected surface while the aircraft is stationary. It can be dangerous when flight is attempted. It also disrupts an aircraft's boundary layer airflow, causing a premature aerodynamic stop and in some cases dramatically increased drag, making takeoff dangerous, which is impossible or dangerous. Super cold large droplet, which called SLD in short form. It refers to ice formed in super cold large droplet SLD conditions, similar to clear ice, but because droplet size is large, it extends to unprotected part of the aircraft and form ice sheets faster than normal icing conditions.
Hello, my name is Farahana. Next is freezing drizzle. Different from freezing rain in that the water droplets are smaller. It's that freezing drizzle may develop in air mass whose entire temperature profile is below freezing. Freezing drizzle can occur without a warm layer above 0 Celsius aloft. Favorable areas for the development of freezing drizzle are in moist maritime areas, preferably in area of moderate to strong upslope flow. The icing associated with freezing drizzle may have a significant impact on aviation. Similar to ice pellet, snow grains imply the presence of freezing drizzle aloft. Next is snow. Dry snow will not adhere to an aircraft surface and will not normally cause icing problems. Wet snow, however, can freeze hard to an aircraft surface that is at sub-zero temperature and be extremely difficult to remove. Very dangerous situation can arise when an aircraft attempts to take off with wet snow on the flight surface. Wet snow can freeze to the windscreen, making visibility difficult to impossible. Next is freezing spray. Developed over open water when there is an outbreak of Arctic air. While the water itself is near or above freezing, any water that is picked up by the wind or is splashed onto an object will quickly freeze, causing a rapid increase in wind and shifting the center of gravity. Next is freezing fog, a common occurrence during the winter. Simply a cloud touching the ground and like its airborne cousin will have a high percentage of supercooled water droplet at temperature just below freezing from 0 Celsius to -10 Celsius. Aircraft landing, taking off or even taxiing in freezing fog should anticipate rim icing.
Today I would like to present about the impact weather hazard on aviation. So the first impact is icing reduce aircraft efficiency by increasing its weight, reducing lift, decreasing thrust and increasing drag. Each impact can either slow the aircraft or force it to downward ice. Icing also seriously impairs aircraft engine performance. So the next picture is the effect of icing on aircraft. Next one is how to avoiding this hazard. First one is flight path operation. Pilot can climb to cooler temperature where the precipitation will be frozen and therefore there will be not an icing hazard. The second one, pilot can also descend to an altitude where the air temperatures are well above freezing. The third one is if encountering clear icing in the freezing precipitation below the clouds of a warm front, the best alternative may be to climb to warmer temperatures across the frontal boundary, as the freezing precipitation may extend the way to ground level. Okay, next one is the second way to avoid this hazard is anti-icing and de-icing equipment. De-icing equipment is equipment to eliminate or remove ice that are already accumulate on the aircraft, while anti-icing equipment is equipment to prevent the accumulation of the ice on specific aircraft surface. The next one is recommended precautions. First one, do not fly into areas of known forecast icing conditions. Second one, avoid flying in clouds temperature from 0 to 20 degrees Celsius. Third one, do not fly through rain, showers or wet snow with temperature near freezing. The fourth one is avoid low clouds above mountain ridges or crest. Expect the heaviest icing with cloud around 5,000 feet above the mountain tops. And lastly, do not make steep turns with ice on the airplane due to increased stall speed. So the next one is case study aircraft crash due to bad weather. So this is Sol Leones Aires flight 5428. So this flight was a passenger flight which crashed near Los Menuques, Argentina on 18th of May 2011, killing all 22 people on board. The aircraft involved is Saab 340, was operating Sol Leones Aires scheduled domestic service from Niquin to Comodoro Rivadavia. So the story about this flight is they get to a certain flight level and then the icing occur on the aircraft, and then the pilot lost control of the aircraft, so then they crash at the Los Menuques, Argentina. So the last one is conclusion. In conclusion, icing one of the most dangerous hazards in aviation. There are many types of icing that can occur. Icing also can give negative effects towards aircraft, or much worse, it can take people's life. However, there are several ways to avoid or minimizing the icing. That's all from me. Thank you.